let us use the equation z cubed plus 1 is equal to 0 to compute the 3 cube roots of minus 1 using complex numbers. Hi there, I'm Ferguson. Welcome to MWF. Now, if we are given z cubed plus 1 is equal to 0, we can also write z cubed is equal to minus 1. Now, our first assignment is to convert both minus 1 and z into complex numbers expressed in exponential form. So first of all, let z equal to r e to the power I theta, where r is equal to the modulus of z, and our theta is equal to the argument of z, and the number I is the number square root of minus 1. So z is equal to r e to the power I theta, where r is equal to modulus of z, theta is equal to argument of z, and I is the number square root of minus 1. Now, if z is equal to that, what is z cubed? Now, z cubed is equal to r e to the power I theta all raised to the power 3. And this, of course, is equal to r cubed e to the power I 3 theta. So let's write here z cubed. Right. What about the number minus 1? The number minus 1 expressed as a complex number in exponential form is equal to minus 1 is equal to e to the power I pi, where pi is the argument of the complex number. So here is minus 1 expressed as a complex number, and here is z cubed expressed as a complex number as well. But the equation says z cubed is equal to minus 1. So this can be equated to that. So let's go ahead and equate r cubed e to the power I 3 theta is equal to e to the power I pi. Now, if two complex numbers are equal, that means that their moduli are equal and their arguments are equal as well. So we can write r cubed is equal to 1, because remember the modulus here is 1. This implies, of course, that r itself is equal to 1. In terms of arguments, we have on this side 3 theta, so we have 3 theta is equal to, on the right hand side, we have pi, which of course means that our theta is equal to pi over 3. Now we need to take account of the fact that when we rotate, every time we rotate a multiple of 2 pi radians, we still get the same complex number. So we have to add the multiple 2n pi over 3 here to the argument to be equal to theta. Now n is the number taking the values, n is equal to 0, 1, or 2. So therefore, our complex number z, remember z is equal to r e to the power I theta, becomes e to the power I brackets pi over 3 plus 2n pi over 3. Remember, our n takes the values 0, 1, and 2. So what is z when n is 0? Let's call it z0. This will be equal to e to the power I brackets. Our n is 0, so it's just pi over 3, which is equal to e to the power I pi over 3. What is the value of z? when n is 1. So let's call it z1. It's equal to e to the power I brackets pi over 3 plus 2 pi over 3. And this is equal to e to the power I brackets 3 pi over 3, which of course is equal to e to the power I pi. And remember, this is equal to minus 1. Lastly, what is z when n is 2? So let's call it z2. Z2 is equal to e to the power I brackets pi over 3 plus 4 pi over 3. Remember, n is equal to 2. This simplifies to e to the power I brackets 5 pi over 3, which can be written simply as e to the power I 5 pi over 3. So our z, which is equal to z cubed, which is equal to minus 1, gives us 3 cube roots of unity, which is the first one corresponding to n is equal to 0 is this one here. The second one corresponding to n is equal to 1 is this one here. And lastly, the last one corresponding to n is equal to 2 is this one here. So these are the 3 cube roots of unity. Remember, the complex, the exponential form here can further be expressed in polar form as, for example, we can take that one there. It becomes cosine of 5 pi over 3 plus I sine of 5 pi over 3, and so on for all of them. For this one here, you put your pi, you get your pi here. Cos of pi is minus 1 and sine of pi is 0. So you end up with a minus 1. So once again, these are the 3 cube roots of unity. Till we see you in the next video. Bye-bye and take care, and please do subscribe. Thank you.